Who's ever used JSON Web Tokens before? Who knows what they are? Okay, all of you who don't know what they are or who've never used them, I will try to explain them a bit in depth and how to use them and tell you what the advantages and maybe the disadvantages of them are. But firstly, let me introduce myself. My name is Sam Bellen and I'm a developer evangelist at Auth0. If you don't know Auth0, we're an identity as a service company, a service provider, which basically means that we make it as easy as possible for developers to implement a secure authentication flow so you can focus on building your actual products, because that's what we want to do as developers, right? We just want to focus on what we want to build. If you have more questions about it, we have a booth here outside. I will be there today and tomorrow as well, together with my colleagues, so come on by. I'm also a Google developer expert. I organize a few meetups, one in Belgium called Frontiers and one in London, which is the Identity and Security meetup. And you can find me on the internet as @SamBegel. So the most important slide of my deck, I have cat stickers. Who wants a cat sticker?
I do.
So we have this wall over there which shows tweets. Send me a tweet with the hashtag FrontCon, and if there's enough cat stickers, I'll just hand them out later at the booth. So I want to see this wall explode with cat pictures, or dog pictures, or horse pictures, whatever you want. Clear? All right. So what we're going to be seeing today is a bit of this. We're going to start with traditional authentication. Then I'm going to try to explain what a token is, a JSON Web Token more in particular. We're going to look a bit about token-based authentication. And if I still have a bit of time left at the end, I will talk about the future of authentication, since we're talking about single-page applications, authenticating. It seems like a cool thing to do. So, traditional authentication, what do I mean with this? Traditional web apps, in my sense or in my brain, are web apps which are generated on the server in PHP.NET, what have you. And all the logic is handled on that server. And the server just generates your HTML, sends it to the browser, and the browser renders this. Looks a bit like this. You have a user who visits your website, and it requests a page. But if that page is protected, you're going to have to log in. Usually you send your username and password or your social login or whatever to the browser. You type it in, the browser sends it to the server. And when those credentials check out, you get back the page. Logic. This is something we all experience, right? Right? Okay, I want to hear some feedback, otherwise I think that I'm saying just gibberish, which could also be possible. So that's a traditional web page. It doesn't only send back the page that you requested, it will typically also send back a session cookie. And we're going to store this cookie in our browser, and every time we want to access a protected page after we logged in, we're just going to send along this cookie. If the session in that cookie is still valid, we're just going to send back the page. If the session is not valid, the user will have to log in again. That's typically how authentication is done with a scenario where you have a server-generated web page. It's still being done today, there's nothing wrong with it. It works like this, so you send your cookie, if it's okay, you get your page back. But there are some differences between traditional web apps and single-page applications. The first one is a traditional architecture just goes browser, server. That server could be multiple, but that server is responsible for most of, if not all of the logic, also the authentication logic. A single-page architecture might look something like this. You have your single-page application living on a certain domain, working in the browser, and it might connect to a few different APIs, a general API, a user accounts API, a payments API, all kinds of different APIs. So suddenly we have to communicate with a lot of more APIs. And you can also have a multi-architecture, and what I mean with a multi-architecture is something like this. You have a mobile app, you have a web app, you have a desktop app. Who's here working on a product that has multiple kinds of apps? One person, 2 persons, 3 persons, 4. Okay, some of you are working with on a product or on a service that has a mobile app and or a web app or a desktop app or a CLI app or what have you. But the funny thing is, we use session tokens for remembering our authenticated state, while the web is the only platform that actually uses cookies, right? A mobile app is never going to use a cookie. A desktop app is never going to use a cookie. That's something that's inherently, that's a property of the web. So it would be nice if we could find a way to authenticate more or less the same for all these kinds of apps without a cookie. So what are some of the problems with a traditional cookie-based approach? Cookies don't like CORS, cross-origin resource sharing. Who likes CORS? You're lying. If you put up your hand, you're lying, because when you have some CORS problems, what do? You fire up Google, you type in, I have a CORS problem, and you open this one Stack Overflow answer that everybody visits, and you do exactly what's written in that Stack Overflow. Because nobody likes CORS, and cookies don't like them either. It's very hard to share cookies over different resources. In fact, it should not be possible. The other thing is, Cookies require state because a session cookie usually contains a session token, which is something that you have to store in your database to see if it's still valid every time the user wants to use this session cookie. So you have to require state. Now, while working with modern APIs, we try to make them as stateless as possible. So that's something that's not really ideal and something we would try to get rid of. The other thing is cookies don't like flow. If you have multiple services, multiple APIs, multiple servers working together, you cannot just pass a cookie which is issued by a certain service or an API to another one because they don't work together. It's issued by this one service, this one domain, and it will only work with this one domain. So cookies don't flow from service to service to service, which can be annoying. As illustrated here, if my main API wants to have some data from my user account API and it needs to be authenticated, you cannot just pass a cookie generated by the main API to the other one. It will not work. So what's the solution? Maybe it is token-based authentication. We'll see about that later. But before we talk about token-based authentication, what is a token? Is there somebody who wants to guess what a token is? Like, give me a one-sentence definition of what a token is. No?
String.
A string, and I'm happy to say that it's a string because it is, but there's different kinds of strings. So let's get started. To me, a token is a unique identifier representing something. Something. So if you take this token, you can identify something. Do I still have a valid session? Is this a user ID valid or whatever is in the token? So it's something unique, hopefully, that represents something. And there's a bunch of different kind of tokens. We'll see a few of them in this talk. The first one is an access token. Who's ever used an access token? Okay. An ID token. Few less, but still a lot. A refresh token. Okay. These are some of the commonly used tokens when working with a token-based approach for authentication. So these tokens are often an opaque string in the form of a UUID. That's what I think you meant. There's a UUID, it's a string, and it's unique. But they don't have to be an opaque string. They can be certain other things, like it can be XML if you're using the SAML protocol, for example, which is a bit outdated, but it's still used a lot. But this XML file or this XML piece of code, whatever, is also a token. And it can also be a JSON Web Token, which is what I want to be talking about today. So JSON Web Token, we at Auth0, we use them as much as possible, simply because we like them, we love them. They're easy to use, and they have certain advantages. And this is a JSON Web Token. And if you've seen a JSON Web Token before, you might have seen that it's made out of 3 different parts with a dot in the middle. Who's ever realized that a JSON Web Token is actually the 3 different parts? Okay, cool. A lot of you. I didn't notice the first time I saw this because I thought it was just some random characters and I didn't even notice it did 2 dots and I didn't realize it was 3 different parts. But it is. A JSON Web Token will always be made out of 3 different parts. And the first one is called the header. And the header just contains some information about the JSON Web Token itself, which algorithm is used to sign this token, so later on we can verify that it's still valid, that it's not been tampered with, and what it is. It's a type JSON Web Token. So JSON Web Token tells you that it's a JSON Web Token, which I think is pretty funny, but it's one of the pieces of information you can find in the header, the first part of your JSON Web Token. And what this is basically just a base64 encoded JSON object. So if you would decode this piece of text there, you would get this JSON object. The same goes for the payload. This again is just a base64 of a JSON object, and this can be a lot of things as long as it's valid JSON, and could be something like this. It's a payload, which means that it has some information which might be interesting to you, the consumer of the token. It might be the subject, the user ID. It might be my first name, my family name, my preferred username. When it's issued, when the token has been issued, and most importantly, it can also contain when it expires. So here we notice something that's very strong about JSON Web Tokens because it contains, or it can contain, an expiry date. So based off of the contents inside of this token, you can already see if it's still a valid token or not, which is pretty cool. And there's a bunch of different claims which you can put in this payload. A claim is just a key value pair. And the first one are reserved claims. And these claims are basically just the claims that are specified in the JSON Web Token spec. So the subject, issuer, issue date, expiry date. There's a few others, but these are just from the spec itself. The second type are public claims, which is not really mentioned in the spec, but there's a document by Ayana which has a whole list of these claims just for API interoperability, that your API expects your first name to be given name, and all the other APIs that use a JSON Web Token should use it as well, just so you know that a first name is a given name, a last name is a family name, stuff like this. So this is not the spec, but there's a whole document by Ayana which specifies a lot of other claims. And then the third type is private claims. And these are basically just anything you want to put inside of the payload of a JSON Web Token. As long as it's valid JSON, you can put it in there, but don't put sensitive data in there, since it's just a base64 encoded JSON object. Anybody can decode this. So don't put credit card numbers or any other sensitive data in there. Clear? Okay. The last part is the signature. And this is an important part of a JSON Web Token, which means that we can verify if it's still a valid token, if it has not been tampered with, if somebody hasn't changed the content of the payload or the header. So what you do is you take a base64 of your header, add a dot, and then you take a base64 of your payload, run them through a signing algorithm like HMAC, there's a bunch of others, and you just give that string and a secret to that algorithm, and it will give you a signature. And should something inside of your payload or header change, the signature will not be valid anymore, since you need to know the secret to create a new valid signature. So JSON Web Tokens can be verified. You can know for sure if somebody has tampered with the payload of your JSON Web Token, which is cool. It's something that makes it more secure. Instead of just an opaque string, a piece of random character or seemingly random characters, now there's content inside of this string. You can know when if it is expired. You can know if it has been tampered with. JSON Web Tokens can be verified. So you take your signing algorithm and you add a super secret key. Maybe it looks a bit like this. You should never give these secrets to anybody else except yourself. Of course, it's a secret for a reason. So yeah, so let's try this out. If you base64ify your first header JSON, you do the same for your payload, and then you run it through an algorithm. You get your three parts, your header, your payload, and your signature. And then you just add some dots in between them. And if I would copy this, hopefully, we can see that the content is the header and the payload that I put into it. So by just taking some base64s and signing them, you can create a JSON Web Token. You don't have to know how to do this manually, because there's libraries in almost any language out there that do this for you. But it's nice to know how it actually works. So, some real-world examples. An access token doesn't have to be a JSON Web Token. The auth spec doesn't specify what an access token should be, but it can be an access token. And it could look a bit like this. It contains the issuer, the subject, my audience, when it's issued, when it expires, which scopes this token is valid for. So it gives me a lot of information I need to access a certain resource or not access a certain resource. Another one is an ID token. And an ID token is something from OpenID Connect, which contains some more information about the identity of the person which has been authenticated. And it could look a bit like this: a nickname, my name, which is my email address for some reason, my avatar, my picture, identity-related information you want to know on authentication, so you don't have to do an extra request to an user information endpoint, so you can immediately show the name or the nickname or the username or the picture of a user. This is all data that can be found inside of an identity of an ID token. And if you want to do it in some JavaScript, create a JSON Web Token. Looks like this. It's not interesting. It's just a slide to show that it's not that difficult to create JSON Web Tokens from scratch if you want to. So we've seen that the signature now was always based around a secret, which is a symmetrical algorithm, or symmetrical signing algorithms use a secret. There's also asymmetrical algorithms which require a private and public key to sign certain things. There's a bunch of these algorithms. I'm not going to try to pronounce them because it's just letters. But the one in dark are all asymmetrical algorithms. And what this means is that you have a private key which signs your JSON Web Token, and then you have the public key which can verify that it's valid, that it's not been tampered with. It's a bit more secure than just a secret. And there's some advantages for that. For example, if you want to share your keys. If you want to be able to validate my JSON Web Tokens, I either have to give you the key, the secret, which I created, or I can just share a public key with you, which means that you can validate my tokens, but you cannot create them. You can just make sure that they're valid. This is often done with JSON Web Keys, another JSON Web something, which looks like this. Again, it's a valid JSON object with some information about your public key. And using this JSON Web Key, you can verify if a JSON Web Token has been tampered with. If you follow the OpenID Connect specification, the location of this JSON Web Key, if you use it, is often can often be found in this file. So there's this .wellknown/OpenID configuration. If you implement OpenID Connect, it will be there, and it contains a lot of information about your configuration. And one of the things is my JWK URI. So if you go to that one, you'll see that this is my JWK. You can use this JWK to verify any JSON Web Token that I have issued. So I don't care if you can see this or you can see this, because you can only verify my tokens. You cannot create or alter my tokens and sign them again, because you need my private key for that. So that's one of the advantages of using private and public keys instead of a secret, because when you use a secret-based approach, a symmetrical algorithm, you can sign and you can verify the tokens. Is that clear? Yes, maybe. Okay, let's move on. So these URLs are just standardized by OpenID Connect. You have to learn them, you can Google them, but it's nice to know that you can find this information about any resource that's using OpenID Connect if you want to. So JSON Web Token, JSON Web Key. There's also JSON Web Signature, which is just a signature to prove that something is signed. It's basically the bottom part of a JSON Web Token. There's also JSON Web Encryption if you want to encrypt some data. I'm not going to go deeper into those because I only have 40 minutes. But there's a lot of JSON Web stuff which is related to encryption and signing, just to make it easier for us web developers to use those things on the internet. Because we all know how to use JSON, right? I think so. So let's make a little comparison. On the right, you have a Belgian passport, and we have everything in 4 languages, because why make it easy if difficult is also possible? But on that passport, there is the fact that it's a passport issued by the Kingdom of Belgium. And you can kind of compare this with the header of a JSON Web Token, because a JSON Web Token header says that it's a JSON Web Token, and it has been signed by this algorithm. So it's a bit of metadata about the thing that we're looking at, the passport or the JSON Web Token. Now, if we open this passport, you can see that there's a bit of information about me. For example, my name, my surname, my expiry date. And this is something that you can compare with the payload of a JSON Web Token. It can also contain things like my name and my surname and the expiry date of the JSON Web Token. So more or less, a payload is the same as the inside of a passport. And then, of course, the signature proves that it's valid. Any passport has a few things that prove that it's valid, some UV light, holograms, and maybe some fingerprint thingies. So in essence, a JSON Web Token is a passport that lets you prove that you have the permission to visit something if you use it as an access token. Clear? Let's move on. So let's see it in action. Let's see, have this beautiful app right here. It has 2 buttons. I'm still logged in, so let's go again. It has one button that lets me get dog pictures because I like animals. But it also has a button that lets me show cat pictures. But cats are not dogs, right? Cats are a bit more, let's say that dogs are easy and cats are not. So I need to log in to see these cat pictures. So what do? I log in. Let's use Google. And when I'm logged in, I can see cat pictures. How many pictures do you want to see? I can keep on clicking. Actually, I just want to see my own cat. This is my cat. So now we can move on. So we have this very simple app that has an API that can give you either cat pictures or dog pictures. And the dog pictures API endpoint is just free to use by anybody. And for the cat picture API endpoint, you need to be authenticated. Now, if we look at this from purely an API, we have the same thing. we do a dog request /dogs, we get a picture of a dog. If we do a private cat request, we get no authorization token was found, because anytime we do a request to a protected resource, we need to verify that we're able to connect this, not connect, but to access this. So we'll send along a token. First thing we're going to do is we're going to get a new token with my authorization or authentication endpoint, copy this, and send this along as the bearer. And once I send along this JSON Web Token, I can get cat pictures. Cool, but one of the strengths of JSON Web Tokens is that it contains a lot of information, right? So if you would take an expired JSON Web Token and use that one instead of a valid one, my middleware will already know that the expiry date inside of this JSON Web Token is invalid, so it will not give me access to this resource since this JSON Web Token is not valid anymore, it's expired. The same thing goes for an invalid signature. So if I change something in the payload, the signature will not be valid anymore, so I should not be able to use this token to get access to a protected resource. And it will say so, your signature is invalid. There's a lot of other things you can test. For example, if your JSON Web Token is malformed, if it's not a valid JSON Web Token, it will say so. So inside of this JSON Web Token, which looks like a stupid string, there's actually a lot of information you can use to either allow somebody to access a resource or to disallow somebody access to a resource. Okay, if you want to know more about JSON Web Tokens or you want to decode or encode your own tokens, there's this website called JWT.io. It's made by us, as a disclaimer, but it has this nice debugger. If you paste in a JSON Web Token, it will show you the contents. If you change the contents on the right, it will give you a new JSON Web Token. We don't save these tokens, just so you know. We don't save them somewhere. They're safe in this website. And it will also just list a whole list of libraries which help you use JSON Web Tokens in your own project in a lot of different languages. So if you want to know more, go to JWT.io. So, are there some downsides to JSON Web Tokens? Is there somebody here in the audience who's been thinking like, yeah, that's all cool and stuff, but what in this case? Yes, sir?
Yeah, so how would you handle like blocking of JSON Web Tokens? Let's say you have a, I don't know, client who you don't want anymore in your system.
Exactly. If we go to the next slide. So indeed, sometimes there's a reason why you want to revoke a JSON Web Token, because a JSON Web Token is valid for a certain amount of time until the expiry date has expired or other reasons. But let's say I hire you today as an employee to my company, and I give you access to all our systems or email or CRM or whatever. You have access for them until the JSON Web Tokens expire, but you turn out to be not that good as I thought, so I want to revoke your access. But you still have those tokens maybe saved somewhere, so you can keep on logging in. So I need to find a way to revoke those tokens, even if the tokens themselves are valid. And this is often done by just a blacklist. So you blacklist the tokens you don't need, and you first check the blacklist. And if it's not on a blacklist, you check all the information in the JSON Web Token. It's an extra step. It requires state as well. But it's one of the downsides of JSON Web Tokens, since you trust them to contain all the information you need to verify that it's valid and that they have access to something. If for some reason you need to revoke them, you need to keep a list of the revoked JSON Web Tokens. So it's a bit harder to invalidate JSON Web Tokens. The second thing is, should you leak your secret or your private key, anybody can create JSON Web Tokens which seem valid. So it's really, can be really annoying, so always keep your private keys and your secrets. So these are two downsides of JSON Web Tokens. And of course, don't put sensitive data in your JSON Web Token, since it's just a base64 of a JSON object. Like I said, don't put credit card data for credit card numbers, for example, inside your JSON Web Tokens. All right, so we've seen the traditional authentication flow. We've seen a token. We've seen what JSON Web Tokens are, what tokens are. Let's see how to use them in authentication. So the typical scenario: user goes to the browser, requests your website. But it turns out that the page he wants to visit or the resource he wants to access is protected. Same as always, user provides you some credentials, username, password, or whatever you want. You send it to that resource, but instead of a cookie, you get back an access token. And this access token, like I said, can be a JSON Web Token, doesn't have to be. You're going to store this in memory in your application, your single page application in this instance. And every time you want to access a protected resource from that point onwards, you just give, take this access token and just give it with the request, and if it's a valid access token, you will get your data back. That's more or less the same as we did with a cookie, but instead of a cookie, we use a token, which is just a string or a JSON Web Token. That's what I just said, so let's skip this. If you want to do this in JavaScript, the only important part is the top here. As a authorization header to your request to your API, you will give the bearer token, which is your access token most of the time. So every time you give this access token and it's valid, this request will give you the data you want. So who's ever worked with auth before? Not to be confused with auth0, auth. Who's ever worked with OpenID Connect before? Well, just a few people. What you need to know is that OpenID Connect is basically you take auth and you add on top an identity layer, which just can give you more information of the identity of the person authenticated with an ID token. But all the rest is just the same as auth. And in a typical auth or OpenID Connect scenario, you have your single page application. We have two different APIs in this example, and we want to log in, so we send our credentials to our account API or authorization server, and if they match, we get our access token back, same as before, but we're not only getting an access token back, we can get back a refresh token if you want to, you can get back an ID token if you need it. So it sends back a lot of tokens, which you're going to save in memory, and every time you want to access an API, you're going to send that access token just to prove that you have access. And you get your data back. But since we're just saving these tokens in memory, does this mean that we have to log in every time the user visits your website? That would be annoying, right? Who wants to log in every time he visits the website? I do not. No. So the login flow remains the same, but instead of these tokens, we also get back a cookie. So we're back to a cookie-based approach. And every next time we visit our website, we will send this cookie in the background, usually in an iframe, to our authorization server. If the session in this cookie is still valid, we get our tokens and we save them in memory. So in the background on Bootstrap of your application, you will send this cookie to your authorization server and request new tokens. This has some benefits that you can refresh your tokens, create new tokens every time the user visits your website, and you don't have to save them somewhere persistently like in local storage or in a cookie or in session storage or what have you. So they're not vulnerable to cross-site scripting, because if you store them in local storage, everybody knows that with JavaScript you can access the local storage and steal these tokens, and once these tokens get stolen, you're in big trouble. So you just want to take them in memory. Var token is whatever you want it to be. They're gone as soon as the user leaves the website, but the next time it comes back and we have this cookie, we send it in the background and get the new token. So we always have access to the tokens we need to use our service. And then you send your access token, of course, to the API. This was the auth implicit flow, and a few months ago, the IETF, the Internet Engineering Task Force, published a new best practices document in which they say not to use the implicit flow anymore. Some of you might have heard of this or might have read this. And what they recommend now is I'm going to try to read this, authorization code with proof key for code exchange, PKCE flow. That's a whole lot of words. It basically looks a bit like this. Your user wants to authenticate. It sends its credentials together with a code challenge to your authorization server. It gives you back a code. You're going to do something with this code. You're going to sign it or whatever. And then you send that code together with a verifier back to your authorization server. That way it can be sure that it was you who did this request, and you get your tokens back. So it's 2 steps more, but it's more secure. And in the end, you get your tokens and cookie back, and you can do the same thing. So, does this approach solve CORS? Who says it does? You're like, maybe? I think it does, because you can just pass along tokens from server to server, from origin to origin, as long as all origins know how to validate those JSON Web Tokens. So you can just pass these tokens along, and anybody who needs to know if they're valid should be able to know if they're valid. So it does solve CORS. Does this approach solve flow? The flow of cookies from one API to the other? Who thinks it does? I do. because you can pass along tokens from one API to the other as long as all of the APIs know how to validate these tokens. So if you share your JWK or your secret with the trust parties, you can just pass them along and they will all be able to validate if it's a valid token or not. Does this approach keep solving state? The things it does. It kind of does. I mean, in theory it does, but if you want to start blacklisting it, like the mister there asked me, you still need some state. If you want to do it secure and send that session cookie every time you authenticate, you will need to keep some state. So in theory, it should be able to solve state. In practice, to do it secure, it does not solve state. All right, we still have a bit of time, so let's go into the future of authentication, since we're talking about single web applications and stuff like this. Who hates putting in a username and password every time he visits a website or he wants to authenticate? I want to see all hands because I don't think there's anybody who likes to put in username and password. Maybe there's a way that we don't have to do this in the future. So let's have a look at this. It's called the Web Authentication API, which became a W3C standard a few weeks ago. Who's ever heard of them? For those who have never heard of it, it's going to blow your mind because it's really cool. It's also called WebAuthn. If you want to Google it, you have a better chance just using WebAuthn than the whole Web Authentication API. And it might mean that we don't need more passwords. We don't need passwords anymore in the future. And you can say, that's not new, we've had password login for a while now. That's true, but that was all just a workaround. You still needed a password most of the time to create your account. It means that we're going to log in with an Authenticator device. I have this little USB drive on my keys, which is an Authenticator device. And I connect it to my computer, and every time I want to access a protected resource or I want to authenticate, I'm going to ask permission to access that resource. The authorization server will send me back a challenge, which is basically just an array buffer with random or semi-random numbers. And this Authenticator device has a private key, and we'll just sign it with that private key. We send back the signed challenge together with a public key to our authorization server, and from that moment onwards, it can always validate your challenges based on this public key. And if you try it out, let's get some space. So I just plug this in. If I press this button, Chrome will ask me to touch my USB drive, my Authenticator device. And once I do so, I have to give permission because I'm a local host. But I get back a public key. I get back a signed challenge. And based on this signed challenge and public key, I can then judge if you're authenticated or not, if you have access to a certain thing. So instead of typing in a username and password and checking those in the back end, I use this public key and signed challenge instead. And you might ask yourself, who has an Authenticator device? So who has an Authenticator device? Like 5 to 10 people? And I'd like to think you're all wrong, because who doesn't have a phone or laptop that's older or newer than, let's say, 10 years? Who has a phone or laptop that's newer than 10 years? All of you. I think all of you do. And most modern chipsets, like the ones of Intel or AMD, if you have a MacBook Pro, there's an A2 chip. All of them have a dedicated chip to do just this. They do nothing more than having a private key and signing things if something needs to be signed. So instead of using this USB drive, which I just plugged into my laptop, we can do something like this. My laptop has Touch ID, so it has a fingerprint reader. And if I click on this, it will ask me to just touch it. I did so, and then again, I have to give permission. And I just used my finger together with my A2 chip and my Touch ID to verify that I have access to something to get a signed challenge and a public key back. Isn't that cool? So who has, so who has an Android phone with a fingerprint scanner? You can all use this. Who has a MacBook Pro with a fingerprint scanner? All of the others who doesn't have any of these devices could theoretically also use it, but then just unlock your Authenticator device with a password, ironically, but it's not implemented by browsers yet. The cool thing is that you can just log in with your fingerprint if your device supports it. If you want to know more about this, we have this website, webauthn.me. which is this website, and it kind of just walks you through the whole process of how this works. So if I enter my name, doesn't really matter what you enter here. Let me refresh real quick. Sam. You see that it's getting a challenge. It sends this challenge back to the browser. The browser sends this challenge to my Authenticator device. I choose my built-in sensor. I authenticate with that sensor. And now it signed that challenge, and we're sending it back to our authorization server. And once everything checks out, we get back our raw ID and our public key. So the next time we want to authenticate, we just use this raw ID. We go to our authorization server, request a new challenge, send that challenge together with the raw ID to our authorization device, touch it, and we can know for sure if this authorization device has access to your service. So if you want to know more about WebAuthn, visit webauthn.me, like so. Okay, so let's summarize. In this presentation, we saw that using session cookies is hard with single-page applications because of course, because of flow, because of state. Stateless authentication is possible, asterisk, because if you want to have a blacklist, if you want to do it more secure and don't save your tokens somewhere persistently, you need a session cookie. So it's possible, but not really. JSON Web Tokens consist of 3 parts: the header, the payload, and the signature. And in the future, we might be able to use WebAuthn. If you want to know more, JSONWebToken.io, webauthn.me. We have a whole blog post about the difference between the implicit flow and the PKCE flow and why you should use the latter one. And our blog is full with useful resources. If you want to see the slides again, you can find them at jwt.sambego.tech. I will tweet them later, so don't bother writing them down. Questions? And I think this means thank you.
How screwed are you if you lose your Authenticator device?
Not screwed, because you usually have a second factor which lets you revoke access to that Authenticator device. And that's it. You cannot use it anymore, but nobody else will use it once you revoke. Because as soon as you forget the public key that it gave you, you will not be able to authenticate anymore with that device unless you register it again. So not really screwed. You just have to realize that you lost it. That's the big part, yeah.
And from the other perspective, for example, I changed my phone and I only have this WebAuthn.
Yeah, so WebAuthn, it's still very new and there's still some things to be figured out, but what you probably will have is a second factor, so you can authenticate and then register this as your second device, so you can register multiple Authenticator devices on your profile, and then any of them will work, so you can register your laptop, your phone, your USB drive. You should be able to register multiple ones.
Yeah, with cookies, you have a table usually with users and how do I explain that? You can't grow this invalid list bigger than this user table, but with JSON Web Token invalidation, you could have the blacklist longer than you have users.
Yes.
So when do you purge the list, or
when the JSON Web Token is not when it expires, you can purge it.
Ah, yeah. Thanks.
You're welcome.
Last question.
Oh. Yeah. Thank you for the presentation. I wanted to ask, is there any times when you should prefer a whitelist instead of a blacklist for JWTs?
If you prefer whitelists.
Yeah. Okay.
I think that's a matter of opinion. Some people prefer blacklists, some whitelists. The thing is, with a blacklist, you usually have a small list. With a whitelist, you end up having a very big list. So checking before you check your JSON Web Token against a whitelist might take a bit longer, which might delay your authorization or authentication process, because you're checking usually against a bigger list, which is the list of accepted JSON Web Tokens, right? So I think in most cases, you will not have that many revoked JSON Web Tokens, and that list, a blacklist, will be smaller. That's why I prefer blacklist, but a whitelist would work as well, if you like that, yeah.
And that's it. Thanks.
Thank you. Thank you.